The Vietnam War saw the U.S. Armed Forces attempt to overpower a determined North Vietnamese foe with superior training and weapons. As the years of conflict raged on, the Soviets supplied the North Vietnamese with more sophisticated aircraft and technology in an attempt to thwart these American efforts. Commander J.R. Hotdog Brown of the U.S. Navy faced this ever-changing threat head-on in the cockpit of his F-8 Crusader. He witnessed the evolution of the U.S. Navy's fighter tactics and training, and helped prepare the next wave of Navy pilots for the life-or-death situations they would encounter in Vietnam.
When I was getting my wings, I graduated #1 in my class that month, and I picked F-4s because that was the hottest thing in the world at the time. And then I picked Demons, the F-3, and all the Demons were old, but they were all transitioning over to the F-4, so I figured, you know, either way I'm going to get F-4s. And the only other fighter we had was the F-8 Crusader, and I put that down because that was the third choice. You had to make 3 choices. And I wanted to be on the East Coast because when I was a sailor, I was on the East Coast, and I was pretty familiar with it. So I picked East Coast, East Coast, East Coast for all 3 of those slots. Well, my orders came, Crusaders, Miramar, California. I didn't get my coast. I didn't get my first choice, my second choice. I got my last choice. And I went to the skipper and I said, "Skipper, what's with this? I worked really, really hard to be #1. I should have got my first choice." And he said, "Son," he says, "you're too young to understand, but you did get your first choice." He says, this is the job everybody wants. They want single seat, supersonic, San Diego, California. You are going to the place for fighter pilots. And he was absolutely right. You taxied down the runway, and there was what we call the gun pits, but it was a square, long, rectangular building where you would put the airplane and you would sight in the guns. And it was right along the taxiway. And so as you came along there on the side of the gun butts building, it said Fighter Town, USA. That's what it said, Fighter Town, USA. And so, there you were, man, right there in San Diego, with Fighter Town, USA. So I started flying Crusaders, and it was an outstanding experience. The training that you go through the buildup of air-to-air combat, ACM, air combat maneuvering. So when you're doing ACM training, you start out one-on-one, and you go through different maneuvers, and you have classroom work on them, and they show you what the airplane can do. And you have what you call a VN diagram, which is the speed and the energy that the airplane has when it's maneuvering. So when you pull back on the stick and start turning, you put G's on the airplane. The airplane is built to take 6.5 times the weight of one gravity force. So like your head weighs 40 pounds, so when you're at 6.5 G's, it weighs 240 pounds. So you don't want to turn your head like this because your head will go right down to the bottom of the cockpit. But they teach you how to maneuver against each other, and this is like type airplanes. So both airplanes that's in the training program have the same turning capability, the same deceleration, acceleration capabilities. So it's pretty, you got to be really, really good to get in the range against the same airplane. And then you go through, I think there's, 15 or 16 flights like that. And pretty soon you're one-on-one with the instructor, and he's pulling everything he's got. Up until that point, he's setting you up to see what the airplane will do. Then you go into air-to-air gunnery, and you have a tow plane hauling a 20-foot banner that's 20 foot by 4 feet. and you fire live rounds at that. And you go into the pattern where you roll in on the target and you come down and you press the target, and they tell you, it says, you want to get so close to that banner before you shoot that you think you're going to hit it with the airplane. And on more than one occasion, guys haven't hit the banner. I think you got target fixation, they call it. But you have to be inside of 500 feet with the guns because they just don't have the range and the accuracy outside that. And even though we trained ourselves to get into a guns attack, in reality, we had very few gun attacks where we actually shot somebody with a gun. All the kills up until towards the end of the war and after Top Gun, the Crusaders had almost all the MiG kills, because the rules of engagement required you to visually identify the target before you could shoot at it. So in an F-4, for instance, you had guys taking binoculars and you know, they would be vectored in on a target and they'd say it's a MiG, but before he could shoot a Sparrow, he had to visually identify it as a MiG, and for good reason. On one occasion, I was flying Wing on the Skipper in 1965, and we rolled in and engaged some F-100s that were up in the north part of Vietnam. And without a visual confirmation, identification, we would have probably shot down two of our own. So that totally negated the beyond visual range capability of the F-4. The long-range radar and the long-range Sparrow, which had a head-on capability. So the rules of engagement negated the beyond visual range capability of the Phantom. The situation was, you know, when we first started in 63, 64, the fighters were doing fighter escort, you know, prevent, you know, attacks by other airplanes on our recon airplanes, reconnaissance airplanes. When we came back in 65, you know, the MiG threat was minimal. Nobody ever thought the MiGs would ever come up against us. They did, as you know, and as time went on from 65, 66, 67, 68, those years, they were up in force, the MiGs were. You know, there were probably one or two guys that were pretty good in air-to-air, but they didn't have the skills that we had. And so the MiGs weren't really a threat. They were more, to us in the Crusader, they were more of a treat. Boy, wouldn't it be nice for one of those guys to show up here, we'd get a kill. That was your attitude. The main threat to us as pilots was AAA, anti-aircraft artillery. And it went from 23 millimeter all the way up to 155s, so big, huge artillery shells, in which they would, and they were all visually controlled mainly, but they would barrage us, you know, and we'd be coming, if we came in at 20,000 feet, they'd set all the timers to go off at 20,000 feet. And they used balloons to figure out how high we were, you know, what our altitude was. And then you'd roll in, trying to hit the target with your nose down at the target, dropping bombs and shooting rockets and things and guns. They'd be shoot launching all the time. And then they've got the SAM missiles, SA-2s, surface-to-air 2s built by the Russians. And so they started putting out these missile sites, and so we were in there trying to interdict. Every time we saw something set up like it was going to be a missile site, we'd come in and bomb it, you know, try to bomb it back into dirt. And of course, they're very resilient. You know, they'll just rearrange the dirt pile after you leave. We had to adapt. The Crusader was a slick fighter. We didn't have bomb racks on our airplanes. The F-8E, which was the last version of the Crusader, did have bomb racks. And so they were already able to carry anywhere from 4 to 6 bombs plus Zuni 5-inch Zuni rockets. My airplane, which was the D, had racks on the side of the airplane for sidewinders, but they manufactured Zuni pods, and for each Sidewinder, which carries 4 Sidewinders, two on each side, we could substitute a Zuni pod, which carried 2 5-inch rockets for those. So frequently we would go with 700 rounds of 20 millimeter and 4 Zunis and 2 Sidewinders. And so we had a dual role of target combat air patrol against MiGs. And then we also had flak suppression. We call our missions flak absorbers because we took more than we gave. But we would be the first ones to roll in with guns and Zunis to try to suppress the AAA sites. And we mapped those all out through photographic runs. We knew where they were, and we tried to, obliterate them. And then the bombers would come in, the light attack with their bombs, and hit the main targets. In 66, 67, 68, when we were really bombing the North, I think there was a campaign called Rolling Thunder, where we were just flying lots and lots of sorties. So you fly lots of sorties, you make lots of presentations, you take a lot of risk. The Vietnamese saw multiple targets. They could fly or not fly, they don't care. You're flying over their property, their country. And so they took off when they wanted to, with as many as they wanted to. So if they thought you weren't paying attention, they would come in low. It was their country. They could fly down, Georgetown Pike. They've been down that road many times, and pop up and shoot you out of the sky and disappear into the trees again. And you never see them coming because they had the radar control. They had the visual eyes on the ground. They could see you coming. They had observation posts. They knew you were coming. They knew where you were going normally. And they would ambush you. And the Air Force would come in with big clouds of airplanes. The biggest cloud that we ended up with was 40 some odd airplanes. But nevertheless, they would key themselves to jump you, either coming in or blowing away. At a good time, at the time we were most vulnerable. And so, they were flying a lot of MiG sorties. And as a result of our training, the Crusaders were doing pretty well in kill ratios. And I think we were pretty near 10-1 in 67, 68. The F-4s weren't doing good because they weren't trained in air-to-air combat. The F-4s were trained to exploit their weapon system, which was a long-range radar. They could pick up a target at 60 miles, they could track it, and they could shoot it without even seeing it, head on. A Sparrow missile would just launch, radar controlled, would go down there and shoot the target. You didn't ever have to see him. Not true with a Sidewinder. You had to get behind the guy with a Sidewinder to get an infrared tone, an IR tone, before you could release it. And it had to be within a certain envelope. If you get to a situation where you have to maneuver, you're within visual sight of each other, then you're in a dogfight. And they were coming to a dogfight. We used to say, you're coming to the fight completely unprepared. And so the kill ratio with the F-4s was terrible. They were only allowed to shoot Sidewinders. They had no guns. In very rare occasions would they get a Sparrow shot, a radar missile shot, because they would be inside the range because they were in visual combat and they were at a disadvantage. I mean, even the Crusaders with their training and their maneuverability at low altitudes, below 20,000 feet, we were having our hands full trying to fight these guys. And of course, the F-4 guys didn't have that training. That wasn't part of their syllabus. And so Frank Alt was disturbed by this, and he was commissioned by the Chief of Naval Operations, Admiral Moore, to study this. And he came out with a report in the end of 68, which said we need to change the way we train. Because this is the war we're fighting, not the war we designed for but the war we were fighting, and we need to change the way we train each other. We started between the F-8 training squadron, the Crusaders training squadron, 124, and 121, the F-4 squadron, both of which were at Naval Air Station Miramar, California, in San Diego. The operations department guys got together and said, hey, we need to, Captain Alt, the Alt report says we got to, revise our training schedules here and what we do. And so they came to us and said, we need to understand what we need to do to be able to do air-to-air combat. And so we got together a team, and we developed a course, which became the first fighter weapons course, and it was in VF 121 because we already had ours. And then it became more evident we had to change the tactics as time went on because the enemy would change their tactics, and we'd adapt those. And there was still more collaboration in '69. And then we stood up Fighter Weapons School and separated that out as a separate entity on its own 2 feet. We have DACM, which is dissimilar air combat maneuvering, which was you bring in something different than the airplane you were flying. If you're flying an F-4, you'd fly against an F-8, or an F-4 against an A-4, or in the case of Top Gun, they had the F-5s. And so we said, hey, we need dissimilar too, so we started flying our guys against the F-5s, and they set up a curriculum. It's totally focused on air combat maneuvering and weaponry, air-to-air combat. And they had instructors assigned from the different fighter squadrons, and usually the top guy in your squadrons was hand-picked to be an instructor in Top Gun. It wasn't called Top Gun there, it was a fighter weapons school. It wasn't until, I don't know, probably in the early 70s that it was nicknamed Top Gun. They had a quota system in the early 70s where they would say you could nominate an air crew, a pilot, and a Navy flight officer, a backseater, radar operator, for a class. And they would have a limited number of pilots, air crew in each class, and you go through this curriculum. And each squadron, you obviously couldn't do it when you were deployed on the ship, but when you come back, you'd apply for a slot, and they'd assign you a slot to go through the school. Once the guy goes through the school, he gets a certificate of achievement, and then he goes back to the squadron and he becomes the training officer, the weapons training officer in the squadron. And so you got a guy who's as we call it, the Top Gun trained expert is now in your squadron, and he takes on the responsibility of passing on all the Top Gun capability to his pilots and aircrew through his training program. When I was in 124, I was sent there as a senior LSO, landing signal officer, because they had just sent the F-8J to the fleet. They tried to design it so that it would approach the ship slower by having airflow blown over the flaps and the slats, which gives it a much more of a lift and a slower speed. But in the process, it takes bleed air off of the compressor of the engine and causes the thrust to be less. And so you got a real dog coming aboard the ship. And because of that characteristic, the people at the Patuxent River Test Center said it wasn't suitable for carrier aviation. And the powers to be bought it and sent it to the fleet anyway. And so I had finagled a set of orders to go to test pilot school in a very short turnaround. And my orders came across the desk of Captain Bob Rasmussen, who was the senior detailer for fighter guys. And he goes, "That's Hotdog Brown. He's a Crusader LSO. Do not pass go, do not collect $200, go straight to Miramar and take over the training of the carrier aviation guys and teach them, including the LSOs, how to bring this aircraft safely aboard the ship, even though the test pilot guys say it's not suitable. Well, I got there and they went, "Hey, Hotdog, here's the old fighter guy, 2 combat tours." Automatically, I'm in operations as a combat flight instructor. So I got 2 roles, major roles there. And I knew all the guys in there. I was about ready to make lieutenant commander at the time. And so I was one of the senior guys in there. And they put together this little cadre of guys working with the 121 guys. I wasn't actually one of those guys doing all that work. I was in ops working with those guys, feeding them the information they asked us for. And then we'd red team, what they came up with. And, it was a good thing. It was a good thing for all of us. When you talk about things, it becomes more clear. I mean, it's nothing more clear than thinking you're the world's greatest fighter pilot and then coming to the training squadron, the RAG as we call it, the replacement air group, and then trying to teach somebody who just came from the training command with bright-eyed and bushy-tailed what the Crusader is all about, how best to fly it, and how best to fight it. You think you know a lot, and you do, but then being able to articulate that in an instructor mode tells you how much you really don't know about the airplane you've been flying for 2 or 3 or 4 years.
Having someone come occasionally who likes a headline.
We'd have instructor meetings and say, geez, I got this question today, and everyone goes, "Oh God, I'm glad I didn't get that," And so you'd go into the books. You had tech reps, technical representatives from the different airframes. The engine guys, would come in and talk to you about the engines. They'd come in and talk about the airframes. They come in and talk to you about the weapons in a technical sense, so that you actually knew how these things worked. You weren't just guessing, or you weren't just trying to teach somebody because you had 1,000 hours more than he had. What you do in this school is, it stands to reason that if you're an instructor, you're better than the student. So the student doesn't learn anything if you go out there and kick him every time he flies. All right? You got to dangle the bait out there. You got to show them what you're trying, you do the classroom work, and we use stick airplanes and show the different angles off and maneuverability. We go over the maneuverability characteristics, the diagrams, the VN diagrams, if you will, of each particular airplane. And it changes as you burn off fuel. You're more maneuverable with less fuel. And so you have to have an awareness of what your envelope looks like if you're at 30,000 pounds versus 25,000 versus 20. Your maneuverability changes. And you don't think about that when you're a nugget flying around. You know that because you learn it when you're an instructor. You go, geez, I got to teach these guys how to do this. And oh, wow, this is what the airplane looks like on paper when it's at 25,000 pounds gross weight. Because the thrust is always the same, and the airframe is always the same. So your speed and acceleration is less when you're heavier. So it stands to reason you're less maneuverable when you're heavier. It takes a special kind of guy, I think, to be an instructor, because you got to put your ego in your back pocket, because you don't know everything. And for you to take a student out and say, okay, we're going to go fly one-on-one, and then he goes and makes a big error or something like that relative to what you would do, and then you end up in 2 turns and it's 6 o'clock, and you go, see, you're an idiot. He didn't learn anything, because you're expected to be that much better than him. But you go 16 flights down the line as an instructor, and you're doing your job. When he's down at that last graduation ceremony flight against you, he's out there to show you he can beat you. And sometimes they do, because you've taught them well if they can beat you. And that's what the goal is. The goal is not to go out there and beat him every time. The goal is to go out there and teach him how to beat you.
The design of the McDonnell Douglas F-4 Phantom II has surpassed 60 years. Initially intended for carrier-based operations, it swiftly evolved into one of the most significant land-based tactical aircraft in the Western world. Over 5,200 Phantoms were manufactured, and today they continue to serve in Greece, South Korea, Turkey and Iran. Originating in the early 1950s as the McDonnell AH-1 supersonic attack aircraft, it transitioned in May 1955 into the F-4H-1 two-seat fleet defense fighter. With its Mach 2 Plus performance, the F-4 boasted an armament featuring 4 Sparrow air-to-air missiles, semi-recessed in the lower fuselage and complemented by a robust search and fire control radar. Thus, the F-4H emerged as the world's first fighter equipped with self-contained search and destroy capability. On May 27, 1958, the XF-4H-1 prototype made its debut at Lambert Field in St. Louis, with test pilot Bob Little at the controls for its inaugural flight.
Our intention on that flight was to take the airplane supersonic on its first flight. We had done that 4 years before in the F-101, and it was certainly something to be accomplished in the F-4. It didn't work out that way. Landing gear didn't come all the way up. And on that flight, a hydraulic system failed on takeoff, so had to bring the airplane in after about 20 minutes of learning how to fly it well enough so I could land it.
Despite encountering challenges during its maiden voyage, as the XF-4H taxied alongside examples of McDonnell's other major fighter program of the period, the F-101 Voodoo, it became evident that the company had a triumph on its hands. The narrative of the Phantom also encompasses General Electric, which supplied the J-79 turbojet engine. In 1951, the company embarked on developing a new axial flow engine that aimed for low weight and excellent fuel efficiency at Mach 0.9, while still possessing the strength and thrust for Mach 2 performance. To accomplish this, the J-79 incorporated innovative design elements, notably the variable stator compressor with adjustable blades and an afterburning exhaust nozzle essential for lightweight and optimal performance at very high speeds. This nozzle utilized secondary air to regulate the expansion of the primary exhaust, also serving to cool the engine, thus obviating the need for costly metallurgical solutions. Mechanically interconnected, 2 sets of nozzle fingers dynamically adjust, opening and closing to shape the exhaust for optimal balance between thrust and fuel consumption across the engine's entire operating spectrum. This innovation results in a substantial 2/3 boost in thrust, albeit at the cost of exorbitant fuel consumption. The full-scale variable stator compressor unit underwent its inaugural test in August 1953, yielding performance figures so impressive that the test crew initially suspected instrumentation malfunction. At much the same time, the afterburner was connected to a J-73 turbojet and tested with encouraging results. The integration of the afterburner with the J-79 engine culminated in the complete new engine's placement in the test cell by June 1954. Approximately 150 hours of testing on the J-79 was supplemented by an additional 800 hours on the J-73 for further evaluation. A pivotal moment in the test program occurred with the inaugural field run of the J-79 engine. Upon ignition, the test crew promptly scrutinized the instrumentation. Subsequently, with the engine throttled to idling speed, ground and flight test engineers meticulously inspected it for any signs of fuel or oil leaks and other potential failures. Once this initial examination was cleared, the engine underwent higher speed testing before being shut down. In May 1955, the groundbreaking new engine took flight, housed in a nacelle beneath the belly of a converted North American B-45 bomber. Historic footage captures the modified B-45's ascent on May 20, 1955. After the B-45 achieved stable flight, the J-79's nacelle was extended, facilitating initial test runs to confirm its capabilities in steady, level flight. Subsequent tests included air starts, essential for any advanced engine. The J-79's performance was thoroughly assessed across various flight conditions, proving its mettle with afterburning thrust ratings of up to approximately 13,000 pounds. The inaugural flight-worthy J-79 was transported across the United States to Edwards Air Force Base in California, where it underwent unpacking, ground testing, and installation for flight trials. This process proceeded smoothly, with fuel, oil, and over 100 electrical connections established without major issues. The XF-4D-1, a prototype of the high-performance Naval Interceptor Skyray, was selected as the test aircraft for the flight trials. Ground runs were conducted at both dry and afterburning thrust levels to validate the fundamental installation. On December 8, 1955, under the command of test pilot Roy Pryor, the aircraft equipped with the J-79 engine embarked on its maiden flight. Taking off downwind to maximize runway utilization, the aircraft required approximately 6 miles of the renowned dry lake bed at Edwards, formerly known as Murrock, until 1950. The flight encompassed a climb to 18,000 feet before safely returning for an evening landing. The entire flight operation exemplified successful flight testing. The J-79 was soon cleared for operational service, and early examples of the type were installed right from the beginning of the Phantom's production run. By the late 1950s, the Phantom's prominence surged following the placement of its first production contract in December 1956. This overview of an F-4B naval model, temporarily loaned to the US Air Force, highlights the aircraft's key attributes. Positioned at the front is the pilot, with the radar officer seated behind. A ladder, visible inside the rear canopy, can be deployed to darken the cockpit, ensuring optimal conditions for viewing the radar screen. Despite being relatively spacious and conventional for the era, the cockpits are well equipped with displays and controls. Occupants are seated on Martin Baker Mark V ejector seats, engineered for safe ejections even at zero altitude and speeds as low as 150 miles per hour. Mach 2 performance is facilitated by the 2 fully variable ramp inlets for the J-79 engines. A splitter plate diverts the boundary layer of the slower moving air close to the fuselage, while the inlet ramp adjusts at speeds exceeding Mach 1.4 to regulate the shock wave pattern, ensuring an uninterrupted airflow into the engine. This system operates automatically, controlled by the aircraft's air data computer. Notably, Navy and Air Force Phantoms typically feature distinct tyre configurations. Both types of tyres boast the same diameter, but the Air Force variant, depicted on the left, showcases a broader design. This broader tyre offers an increased touchdown area, allowing it to be inflated to lower pressures, suitable for operations on the extended runways typically available to land-based aircraft. Positioned on the port side of the fuselage is a pneumatically extended ram air turbine, serving as an emergency power source to sustain essential systems in the event of engine failure. Operating down to a speed of 225 miles per hour, the turbine supplies electrical power, transitioning to hydraulic power for the landing systems thereafter. The centerline hardpoint for Stores Sidewinder Tactical Optical Recognition carriage is augmented by 4 substantial pylons situated under the wings. Along the leading edges of the wings are 3 section slats designed to maintain an even airflow over the wings and reduce stalling speed. This feature's efficacy hinges on boundary layer control, achieved by tapping air from the engine compressor and venting it through the depicted slots. This is one of the 2 trailing edge flaps, which are also fitted with boundary layer control. Similar to the leading edge system, these slots direct air tapped from the engines over the upper surface of the flap. This airflow manipulation enhances the effectiveness of these relatively small surfaces. The flaps have a maximum deflection of 60 degrees, with full flap setting employed during landing and half flap setting for takeoff. Lateral control is achieved through a combination of spoilers and ailerons, with spoilers utilized at high airspeeds and ailerons at low airspeeds. Each wing's underside features a hydraulically operated speed brake, enabling rapid deceleration from speeds as high as Mach 2.4 at any flight altitude without inducing buffet or altering pitch trim. Although extending the speed brakes during landings is safe, their effect is minimal at low speeds. The elongated low vertical tail addresses headroom constraints on US carriers' hangar decks and incorporates a powered rudder for yaw control. Beneath the powered rudder lies the vent for the fuselage's complex of 6 fuel tanks. The slab tailplane halves ensure complete pitch control under all flight conditions and are angled downward at 23 degrees to enhance directional stability by augmenting the effective side area of the rear fuselage. Positioned between the J79 tailpipes is the arrestor hook, typically housed beneath the rear fuselage fairing but deployed during carrier landings. This feature, retained on land-based Phantoms as well, has proven invaluable for achieving short landings on runways equipped with appropriate arrestor gear. Crafted from a special high-strength alloy, the hook is engineered to withstand the immense forces encountered during arrested landings. Heat resistance in the rear fuselage is enhanced through the utilization of stainless steel, titanium, and ram air cooling. Located at the far end of the tail is the compartment for the 16-foot braking parachute, essential for reducing landing distances on standard runways. The aperture in the tail facilitates the exit of cooling air, intentionally drawn into the rear fuselage structure above the engine exhausts. Renowned for its distinctive appearance, the Phantom has always stood out in the realm of aviation aesthetics. One of these distinctive features is the power folding of the outer portion of each wing, normally angled at 12 degrees. The folding system is engineered to reduce the Phantom's width for ease of movement on carrier decks and elevators. This feature, retained on land-based Phantoms as well, has demonstrated its practicality in various operational scenarios. With the wings folded, the internal plumbing for the boundary layer control system becomes visible. The sizable nose radome accommodates the 32-inch diameter antenna of the APQ-72 main radar. Positioned beneath the nose is the fairing for the infrared scanner, serving as a backup target acquisition capability should the main radar encounter jamming or failure. The Phantom entered operational service with the US Navy in 1961, prompting rapid conversion of squadrons from older aircraft types to equip the Navy's formidable carrier force. The section illustrates key elements of carrier-borne operations, featuring F-4Bs from Fighter Squadron 74 aboard the USS Forrestal, the Atlantic Fleet's inaugural Phantom unit, also known as the Bedevilers. Prior to each mission, a meticulous briefing sets the stage, followed by flight crews donning survival equipment on top of their flight suits. Upon the command from flight operations, crews proceed to their designated aircraft. Meanwhile, deck crews, distinguishable by different coloured vests for identification, finalise preparations for the mission launch. The pilot conducts a thorough walk-around check of the aircraft before both pilot and radar officer embark on the Phantom. The launch weight is indicated for the catapult officer's attention. In the fleet defense role, the pilot assumes control of the aircraft and oversees combat operations, while the radar intercept officer manages radar operations and initiates early interception procedures. Subsequently, both cockpit canopies are sealed shut, and the deck crew raises the catapult bridle in readiness for launch. The flight deck director meticulously guides each aircraft into position over its assigned catapult, carefully manoeuvring it onto the shuttle over the wheel section of the catapult. Subsequently, the bridle is securely attached, and any slack in the bridle is eliminated by nudging the catapult shuttle forward slightly. Simultaneously, the companion Phantom on the second catapult undergoes identical preparation. With cockpit checks also finalised, the deck director signals the pilot to advance the engines to takeoff power. Finally, the director signals the launch, and the Phantom is hurled down the catapult run and over the bow of the carrier at a speed of 185 miles per hour. As the first pair embarks on their combat air patrol, another duo of Phantoms taxis towards the launch area. Upon reaching the designated spot, deflectors are raised to redirect exhaust gases away from the flight deck. Simultaneously, the shuttle is repositioned, allowing the next Phantom slated for that catapult to align its nosewheel unit over the shuttle and position itself in line with the catapult while the deck crew raises the bridle. This launch sequence continues with up to 4 aircraft dispatched almost simultaneously. Additional aircraft are brought up via the deck edge elevators. Enabling launches to proceed, including instances of triple dispatchers. Equipped with a 2-person crew, potent radar, and an arsenal comprising Sparrow medium-range and Sidewinder short-range missiles, the Phantom was heralded as the world's first fighter with independent search and destroy capability, free from ground control, and proved invaluable for the US Navy in the 1960s. Its service capabilities were swiftly showcased through a series of world records. In December 1959, the Phantom achieved a zoom climb-to-altitude record of 98,556 feet. In September 1960, it secured 2 closed-circuit records at speeds of 1,217 and 1,390 miles per hour. Less than a year later, in August 1961, it established a low-altitude speed record of 903 miles per hour, followed shortly thereafter in November by an absolute world speed record of 1,606 miles per hour. Undoubtedly, one of the most remarkable early achievements took place in May 1961, commemorating the 50th anniversary of naval aviation. 5 prototype Phantoms embarked on a journey from west to east across the United States, completing the transcontinental flight in a mere 2 hours and 47 minutes, smashing previous records. Upon concluding their patrol, the Phantoms returned to the carrier for landing. Approaching at 150 miles per hour, each aircraft undergoes visual inspection to verify the lowering of landing gear and flaps. They're then guided down by the landing signal officer once the assistant confirms a clear deck. As the pilot aligns for approach, guidance is provided by an amber light known as the meatball, situated on the right side of the flight deck. The pilot keeps this lined up with the row of green lights to ensure that he is in the groove, the correct glide slope to fly the aircraft onto the deck and catch the wire. Different light angle approach settings are configured for each type of aircraft aboard. Following each landing, the wire disengages from the arrestor hook and returns to its position as the landed aircraft taxis clear, facilitating the prompt arrival of the next aircraft. Subsequently, the landed aircraft are lowered to the hangar deck via the 4 deck edge elevators to initiate the maintenance cycle before their next mission. Each of the 4 Forrestal-class ships boasts approximately 3.5 acres of maintenance area below the flight deck, though this capacity accommodates only half of the carrier's 90 aircraft at any given time. Throughout the 1960s and early 1970s, both the F-4B and the upgraded, more potent F-4J versions of the Phantom served as the backbone of the US Navy's air defense. Extending outward to a radius of 400 miles from the carrier, the Phantom maintained unrivaled effectiveness in combat air patrol until the introduction of the Grumman F-14 Tomcat. During the Vietnam War, US Navy Phantoms occasionally operated as attack aircraft from land bases while detached from their parent carriers. These F-4J aircraft, derived from the original F-4B, featured more powerful engines, drooping ailerons to complement the flaps, slotted and hence more efficient tailplanes, and an enhanced combination of AWG-10 fire control radar and AJB-7 bombing system for improved air-to-air and air-to-ground capabilities. The pilot assumes the primary responsibility of flying the aircraft, remaining fully engaged in ensuring all systems are functioning optimally and monitoring fuel levels while maintaining a vigilant visual scan of the sky for potential threats that may have eluded radar detection. In the rear seat, the radar intercept officer employs increasingly sophisticated equipment to monitor the tactical situation and provides ongoing updates to the pilot. The Phantom earned its stripes in Vietnam and remained one of the few US combat aircraft in that theatre never to be withdrawn. Throughout the conflict, it consistently demonstrated its ability to meet the diverse demands placed upon it and garnered deep admiration from its crews. However, the Phantom wasn't without its shortcomings, particularly in its early iterations. One notable flaw was its smoky power plant, which could inadvertently reveal the aircraft's position to adversaries. Another significant operator of the Phantom in Vietnam was the US Marine Corps, with a key marine aviation unit, Aircraft Group 13, stationed at Chile in 1968. Aircraft were stored in blast-proof revetments between missions to mitigate the impact of communist rocket and mortar attacks on airfields and to impede potential close assaults by Viet Cong sappers. Prior to boarding the Phantom, the crew conducts a thorough walk-around check to ensure the aircraft exhibits no visible defects. They inspect the underwing pods to confirm full attachment, complete loading, and proper electrical connection, as well as to ensure the safe handling of the 2.75-inch rockets. Examination of the main landing gear wheel well is conducted to detect any signs of hydraulic or fuel leaks. A brief inspection confirms that the Mark IV 20mm cannon pod is loaded with ammunition and free of apparent issues. The bomb load is finalized with triplets of retarded high-explosive bombs loaded onto the wing pylons by the ordnance crew, utilizing a specialized jack-up bomb trolley. Safety pins are inserted to secure the bombs before the trolley is removed. And safety wires are affixed to each bomb to prevent arming until after release. As it falls, the wire breaks, thus freeing the nose-mounted propeller to turn the requisite number of times and so arm the weapon. The two crew members undertake the standard walk-around check before boarding the aircraft. With assistance from the ground crew, they strap in and then don their bone dome helmets and flame-resistant gloves. The next task involves conducting a cockpit check with the aid of a specialized checklist. All moving surfaces undergo a final visual inspection and testing as the ground crew remove flagged pins and safeties, which are then prominently displayed to the pilot. Loaded with 12 bombs and a centerline drop tank, the F-4B of Marine Fighter Attack Squadron 115 taxis out for takeoff, accompanied by other Phantoms slated for the mission joining up on the runway. Before receiving clearance for takeoff, the crew verifies that the outer wings are securely locked down, then proceeds to embark on another tactical sortie in support of Marine Corps ground forces. As the scope of US operations in Vietnam expanded steadily during the later 1960s, there was a corresponding increase in the expansion and enhancement of bases utilized by aircraft like the Phantom, which necessitated fully paved runways. Marines are depicted laying a temporary extension to a paved runway in the image. Ground operations necessitated support around the clock and in all weather conditions, highlighting the crucial role played by Marine Aviation Phantom squadrons in facilitating the success of Marine Corps ground forces in Vietnam. Phantom pilots took pride in their ability to deliver a wide array of ordnance with precision, particularly in close proximity to friendly forces' forward positions, a capability that proved pivotal in crisis situations. The ability to rapidly respond allowed constant pressure to be applied on the enemy, whose precise location was communicated via radio relay by ground forces or a forward air controller. Waves of aircraft ensured sustained air pressure on hostile ground forces and enabled the deployment of various types of ordnance tailored to the circumstances of each tactical scenario. The US Air Force emerged as a major operator of the Phantom in Vietnam, commencing with the F-4C land-based variant of the F-4B, followed by the modestly improved F-4D featuring enhanced ground attack capabilities. Despite susceptibility to communist guerrilla attacks, centralized fueling systems like the one at Cam Ranh Bay offered tactical advantages, prompting their utilization in Vietnam. The Phantom's high fuel consumption posed challenges for holding quick reaction units on the runway, but often circumstances demanded it to swiftly deploy maximum aerial firepower against communist forces. However, this practice exposed crews to heat fatigue under the scorching tropical sun while waiting fully manned and armed on standby. Despite these concerns, the paramount consideration remained the speed of reaction, ensuring Phantoms could be scrambled promptly when needed. After the standard preparation and takeoff, sometimes with reduced fuel to allow the maximum possible warload to be uplifted, the Air Force's Phantoms often linked up with a Boeing KC-135 tanker to top up their tanks and thus increase combat radius with a warload of up to 16,000 pounds of external stores. Here, the boomer aboard the tanker aircraft guides the boom into the Phantom's dorsal receptacle for fuel transfer. Renowned as the quintessential attack aircraft in Vietnam, the Phantom offered an impressive combination of payload capacity and range, coupled with robust airframe strength and advanced avionics, ensuring precise targeting with remarkable accuracy. This footage, captured during an attack, vividly demonstrates the Phantom's capability to engage heavily defended targets in North Vietnam as effectively as less fortified targets of opportunity in the war-ridden terrain of South Vietnam. Targets outside of South Vietnam included critical communication networks, power plants, and strategic stockpiles, all heavily guarded by anti-aircraft artillery and missiles. Even in adverse weather conditions, Phantoms demonstrated their ability to penetrate defences and deliver their payloads. The Vietnam War saw the deployment of the entire spectrum of tactical weapons by the USAF, encompassing various types of freefall and retarded high-explosive bombs. Retarded bombs were specifically designed to allow attacking aircraft to drop them accurately at low altitudes to maximize the force of the explosion. In coordinated operations, Phantoms would operate in tight formations at medium altitudes, with all aircraft releasing their bombs upon the leader's command to achieve maximum concentration of ordnance. Napalm emerged as a particularly vital weapon in the US tactical arsenal during the Vietnam War. While the initial F-4C proved effective, it underwent development into the F-4D with enhancements such as the APQ-109A radar replacing the APQ-100 and the ASG-22 sight. However, both models lacked an internal gun, leading to the frequent use of cannon pods in both air-to-air and air-to-surface roles. Pictured here is an SUU-16A pod loaded with 1,200 rounds of 20mm ammunition. The pod incorporates an external ram turbine to power the cannon, restricting the aircraft to speeds below 400 miles per hour during the firing pass. Thus, its use was confined mainly to the air-to-ground role, as demonstrated in these sequences of typical ground attack passes. The SUU-16A and the SUU-23A self-powered versions, designed for high-speed air-to-air engagements, served as solutions, albeit not ideal ones, to the Phantom's lack of an internal gun. Additionally, the Phantom operated with air-to-surface missiles like the 12,000-yard range Bullpup. As previously mentioned, its primary air-to-air armament consisted of the medium-range Sparrow and short-range Sidewinder missiles. Although air combat was infrequent during the Vietnam War, encounters with MiG fighters did occur, often resulting in successful engagements, such as the one depicted here with a Sparrow missile, or through cannon fire, as captured in classic camera gun footage. The definitive USAF version, the F-4E, introduced an M61 Vulcan 20mm cannon in the lower nose, along with the smaller diameter APQ-120 radar, uprated engines, a slotted tailplane, and manoeuvring slats on the outer wing panels. Similar to earlier Phantom variants, provision was made for podded electronic countermeasures like the jammer pod, seen here, carried in the port-forward Sparrow missile recess. The Phantom quickly garnered significant export orders and emerged as the Western world's most vital tactical fighter. The Phantom saw service with 11 overseas operators, including Australia, Greece, West Germany, Turkey, South Korea, Japan, Iran, Egypt, Israel, Spain, and the United Kingdom. Despite not being the third largest purchaser of Phantom aircraft in terms of numbers, the UK pursued a significantly modified variant derived from the US Navy's F-4J. Designated as the F-4K for the Royal Navy and the F-4M for the RAF, this variant featured two Rolls-Royce Spey afterburning turbofans. This necessitated substantial revisions to the fuselage, although the additional drag resulting from these modifications offset the advantages of the more powerful and fuel-efficient power plant. The naval variant, known as the Phantom FG Mark I, boasted the AWG-11 fire control radar and incorporated various British features. Its armament included the Sparrow missile and the 2-inch rocket, the latter housed in multiple pods mounted under the wings. The FG Mark I remained in service with the Fleet Air Arm until the Royal Navy was forced to phase out its fixed-wing carrier strength in the mid-1970s. Following the allocation of survivors from the Fleet Air Arm's 52 aircraft, the Royal Air Force operated the Phantom FRG Mark II, equipped with the AWG-12 fire control radar and a British navigation attack system. Peacetime ground attack training typically involved rockets, cannon pods, and practice bombs, as depicted in the accompanying sequence.
About 5 degrees coming on to the attack heading now. Contact the target, master arms going on, and the camera's going on. Going right a bit. Firing now, and pulling. Downwind now for a Florida landing.
Roger, Red Leader, join.
Gears down. On speed.
The 150 British Phantoms primarily serve in air defence roles over the UK, with a secondary responsibility for fighter ground attack missions. Number 41 Squadron exemplifies one of the 7 British Phantom squadrons, with 2 squadrons flying ex-naval FG Mark I variants and a 3rd squadron operating ex-US Navy F-4Js. The latter was necessitated by the RAF's increased commitment in the South Atlantic following the Falklands War of 1982. Modern developments have highlighted alternative roles for the Phantom, such as reconnaissance and defence suppression. One of the most significant developments has been the creation of the F-4ES, high-altitude photo reconnaissance variant of the F-4E, exclusively utilised by Israel. This variant features a completely modified nose section to accommodate special HIA-C1 oblique photo equipment, enabling the high-altitude aircraft to surveil deep into enemy territory while remaining in the relative safety of friendly airspace. Israel is also undertaking upgrades to its fighter models. Additionally, countries like Japan, South Korea and West Germany envision a future for their fighters, following extensive upgrades by their respective aircraft industries. Throughout its service history, the Phantom has demonstrated remarkable adaptability across a wide range of roles, utilizing various weapon types on its 5 hardpoints. Some of the most important are illustrated in the next few sequences. Unguided rockets have played a particularly significant role in area ground attacks. Among the most commonly utilized types are the 2.75-inch rockets, with the 5-inch variants being less frequently employed. These rockets are fired from launchers of various sizes and are effective against soft battlefield targets such as troop concentrations, unarmored vehicles and artillery positions. In the air-to-air role, the short-range infrared-guided Sidewinder has proven more successful than the medium-range Sparrow. The Sidewinder locks onto the heat emitted by the target, providing reliable targeting compared to the Sparrow, which homes in on radar reflections bouncing off the target. The Phantom can carry up to 4 Sparrow missiles under the fuselage and 2 or 4 Sidewinders on underwing hardpoints, offering maximum flexibility in air-to-air engagements. In the depicted sequence, a Convair F-102 Delta Dagger pilotless drone serves as the target. A late-model Sidewinder successfully hits the drone's tailpipe, demonstrating the effectiveness of the weapon. Following the successful hit, the drone experiences successive breakup as it tumbles out of control. Both saturation and precision bombing have been conducted against point and area targets, utilizing a wide range of US bomb types, including highly effective high-blast demolition types. Cannon pods have also proven highly successful in the air-to-ground role, with 20mm pods being more common, although 30mm pods can also be carried. Multiple pods have demonstrated devastating effectiveness in air-to-surface operations. As the most important type in US Navy and US Air Force service during the 1960s and early 1970s, the Phantom was utilized by aerobatic display teams of each service. The Navy's team, the Blue Angels, operated the F-4J until the rising fuel prices necessitated a change to the McDonnell Douglas A-4F Skyhawk in 1974. Similarly, the Air Force's team, the Thunderbirds, flew the F-4E until transitioning to a smaller and more economical type. In this instance, the Northrop T-38A Talon. The Phantom stands as the Western world's most widely built and extensively utilised combat aircraft since World War II, making its production milestones notable achievements in aviation history. The 1000th Phantom, an F-4B for the US Navy, was delivered on July 7, 1965. 2 years later, the 2000th Phantom, an F-4D for the Air Force, followed on February 21, 1967. Just 17 months later, on August 28, 1968, the 3000th Phantom, an F-4J, was produced for the US Navy. An F-4E for the Air Force became the 4000th Phantom on February 1, 1971. Finally, on May 24, 1978, the 5000th Phantom, an F-4E, was delivered to the Turkish Air Force. Although the Phantom is no longer in production, it remains an effective warplane. A classic fighter isn't just one that performs well under ideal conditions, it's one that accomplishes missions beyond its original design. The success of the Phantom was a result of the courage and skill of its crews, supported by an aircraft that was capable and versatile enough to adapt to various missions. The F-4 Phantom was neither pretty nor elegant, but it did its job when so many other aircraft in history could not. That's what counts.
This fighter squadron is flying faster than the speed of sound. These pilots engaged in combat miles above the Earth. It was a truly fantastic concept. But when the first F-100 Super Sabres were delivered to the US Air Force in 1953, that fantasy became a reality. Until then, the only planes to have broken the sound barrier were experimental test aircraft. With the arrival of the F-100, the age of supersonic air combat had truly begun. Their arrival wasn't an uneventful one. New planes set two records, the last subsonic world speed record and the first supersonic world speed record. After 4 years of development, the F-100 ushered in a new era. Ahead lay a long, tumultuous career that would be marked by distinction and marred by crashes and controversy. Overcoming the sound barrier was a landmark achievement, and the F-100 marked the dividing line between the first and second generation of jet fighters. Because the Air Force was just reaching the 100s to give as new plane designations, the first assortment of supersonic aircraft were known as the Sentry Fighters. The Sentry Fighters were renowned and included the F-105, but it was from the cockpits of the F-100 Super Sabres that the Thunderbird pilots would eventually choose to perform their aerobatic magic. The plane had its problems, including landing characteristics that were more like a controlled crash, but in flight, its responsiveness and reliability won the affection of the most critical of pilots. Though Super Sabre was the product of a very distinguished design team, the North American company had been quietly successful since its inception. There had been no upheaval in the company since 1935, and within this stable atmosphere, the designers were encouraged to probe the cutting edge of aviation development. The Super Sabre was born in 1949, when the designers began exerting efforts to take the next major step forward, breaking the sound barrier. By the time the F-100 was developed, North American prided itself on having built the greatest fighters of World War II and Korea. Opinions may differ, but the two aircraft in question, the Mustang and the Sabre, would certainly be contenders for the title. As the third fighter from the stable, the F-100 faced the challenge of living up to this legacy. The company's first fighter was a classic. The P-51 Mustang was truly a legend. It had firmly established the company's name in the world of combat aircraft construction. In the European and Pacific theaters, the Mustang made its mark as a superb escort and attack aircraft. The first flown in 1940, it stood at the end of a long line of propeller-driven fighters and was one of the greatest ever flown. But the P-51 remained in service after World War II, overlapping into the developmental age of early jets. It was still in service in large numbers during the Korean conflict and was a mainstay in ground attack and support missions. North American built over 16,000 P-51s. This massive success with their first fighter project served the company well. It established them as a producer of the first-class fighters, filled the company coffers, and set them up to make their next series of design studies. North American was ready to step into the jet age. It did so with two new planes, the FJ-1 for the Navy and the F-86 for the Air Force. By far, the more successful of the two was the Air Force F-86, thus Sabre. By this time, the company was so confident that the F-86 was delayed for over a year, as the company designers sorted out the problems of giving the plane swept wings and a tail. North American stability and prosperity allowed for that kind of risk-taking, and the resulting aircraft richly repaid the company's investment and patience. Sabres went into mass production in 1949, arriving just in time for their baptism by fire in Korea. The F-86 first went into service in Korea in December 1950. By that time, the Air Force had to run into stiff opposition from MiG-15s, which were also clearly outperforming their American jets. In mortal struggles over the Korean landscape, the newly arrived Sabre established combat superiority over the Russian plane. Better training and tactics, along with technology, for what really carried the day. Meanwhile, the Sabre's designers were tackling a new challenge, the sound barrier. Work commenced in 1949 and progressed rapidly through 1950. Early experiments in extending the capability of the Sabre merely revealed the limitations of its design. The engineers quickly returned to a blank sheet of paper, and in the end, developed a totally new and much larger aircraft. In January 1951, the Air Force gave the nod to this new design. Soon after, the F-100 Supersonic Dayfighter was launched into production. No experimental or X aircraft were ever built. In fact, the first F-100s would be a production prototype or Y plane with typical North American confidence. This went from the drawing board to the construction bay 3 months prior to the Air Force approval. Aviation technology was leaping ahead at the time, and the F-100 was quickly outdated. But the jet was too useful for early retirement and complemented new designs throughout the coming year. The Sentry fighters were the core of the U.S. air power for many years. They represented an enormous commitment to advanced technology and immense capital investment. Their development was a construction and reflected the revolutionary advances in aviation theory and practice. They became the testing ground for innovations in many fields: aerodynamics, materials, methods of machining and construction, engines, avionics, navigation, and fuels. All the changes weren't limited to technology. There was also a revolution in tactics and arms. Chief among these were developments in missiles and nuclear weapons. In time, the F-100 found its niche as a fighter bomber. At the outset, it was designed as an air superiority fighter, but soon gained multi-role capability. The wing was redesigned to carry up to 6,000 pounds of stores on 6 pylons. This enabled the Super Sabre to carry a many variety of weapons and ensured that the plane could pack a heavy punch. The Korean stalemate cemented American determination to be fully prepared for future conflicts, and the whole approach to weaponry was reapproached. Machine guns soon gave way to more powerful weapons. Some theorists predicted that the unguided bomb would soon be replaced by missiles. The idea spread, and a number of F-100Ds were altered to accommodate the bullpup tactical air-to-surface missile. This weapon of the future was guided by the pilot with a cockpit toggle. Like early versions of many things, it wasn't terribly effective. Experience would show that the unguided bomb held a considerable cost advantage over complex missiles. The new weapons also proved to be too expensive for widespread use. Still, their relative accuracy was considered essential in some combat situations. Early F-100 days had some major faults. In part, these were due to design changes ordered after the initial contract had been signed during 1952. These changes included a critical shortening of the tail. This left plane with the very bad roll coupling problems, and after 6 major accidents, the F-100s were grounded. 2 pilots died when, through no fault of their own, their plane spun out of control and then broke up. In response to this tragedy, the tail was enlarged to its original shape and the wings extended. These changes were retrofitted to existing planes and incorporated into the new ones when production resumed. Apart from this very major flaw, the test series at Edwards Air Force Base went fairly smoothly. The only other concern focused on the plane's landing characteristics. This was eventually addressed through the pilot training rather than modifications to the plane. Experiments in zero-length launch were also conducted at Edwards. The F-100 had a range of well under 600 miles. It was later given in-flight refueling capability, either from a tanker or the buddy system from tanks on another plane. As a result, it became capable of extended patrols and long-range strikes. "203 F-100As were built, the first 70 being delivered before the roll coupling problems were corrected. Fixing this delayed the program, and it wasn't until the spring of 1955 that production resumed. By that time, the upgraded F-100C was undergoing tests. The B designation had already been committed to a version intended to fly faster than twice the speed of sound. Design problems weren't limited to the potentially fatal control losses experienced at high speeds. At low speeds, the plane could also be very unforgiving. Here, a pilot realized that he has undershot his landing point and frantically attempts to put his plane back up. In opening his throttle too fast, he included a compressor stall and then, in a series of overcorrections, fatally compounded his problem. This incident was not unique, and the term saber dance gained a new and darker meaning. The F-100 design was not necessarily flawed. The problem stemmed from the plane's purpose, which was to go fast, and many of the characteristics essential in going fast inhibit low speed control. The F-100 stalled at around 150 knots. It was sluggish and unresponsive anywhere near that lower speed. The pilot's forward view was seriously obstructed. The throttle of a slowed-down Sabre jet was touching, and landings were never simple. In the end, the F-100's low speed control problems were never fully corrected. It was just another deadly possibility that the pilots had to learn to live with. Training, experience, and the instinct for self-preservation kept the accident rate down. And most buyers found it safer to strain the undercarriage in high-speed landings than to meddle with the F-100 at low speeds. The Super Sabre embodied the demands of supersonic flight, from the sharp lips of its air intake to the sweep of its wings. Even stationary F-100s gave an impression of speed. There were many innovative touches about them. Fully pivoting slab horizontal tail surfaces were positioned as low as possible on the flattened belly of the fuselage. There were no outboard flaps. Instead, a system of leading-edge slats were employed. Throughout its career, the F-100 had the type of problems to be expected of such an advanced design. In some ways, it was an adventurous experiment. North Americans selflessly circulated information about these problems throughout the American aerospace industry. Though it was information obtained through costly research and analysis, the companies passed it on nevertheless. Because of this, the industry as a whole advanced, and mistakes were seldom repeated. North American and most Super Sabre pilots were well pleased with the plane. This included the famed Thunderbirds Aerobatic team. This loyalty went very deep. Once, they were issued replacement F-105s and finding these not up to par, promptly returning them to their Super Sabres. The Thunderbirds flew the F-100s from 1956 until 1969. They started with the first 6 examples of the C model and stayed with the F-100 from then on. Needless to say, they came to know every virtue and every vice that the aircraft had.
Okay, Thunderbirds, let's do a loop. Play the deck. Nose coming up. Okay, in with the pull. Right on in. Topping the loop now, ease it off. Let it float a little. All right, back in with the pull. Now let's ease it off and play the deck. Smoke off now.
The Thunderbirds also wrote another sad chapter of the F-100 story. After a crash during one of their air shows, investigators turned up fatigue problems in the wings of the plane. It is suspected that some of the Super Sabres that went down in Vietnam may have lost due to the same flaw. This diagnosis led to immediate remedial action, saving other pilots from a similar fate. The Thunderbirds' performances with the Super Sabre are proof that even if practice cannot make perfect, it can come very, very close. These thrilling planes were not specifically built supermodels. They were stock aircraft, maintained and flown for a specific purpose. The Thunderbirds exaggerate and embellish normal maneuvers in a choreographed sequence that appears to push the aircraft into unusual or extreme conditions. But each pilot is a pro, and the test is to match his ability with that of the plane. Because of the high accident rate, a 2-seat version, the F-100F, was developed to familiarize pilots with the plane. This effectively transferred the bulk of the accident rate onto the trainers. The F model suffered heavily. Over 1/4 of them were lost in non-combat mishaps. Each airplane imposes its own demands upon a pilot, and the F-100 was the first of a new breed. Because of this, all personnel transferred to it were given an extra intensive training. With the revolutionary advance to supersonic flight, pilots needed to start training all over again, because jets not only greatly increase speeds, but they drastically reduce the pilot's room for error. In combat against Japanese Zeros and North Korean and Chinese MiG-15s, the American military learned that advanced pilot training and tactical discipline can overcome technical disadvantages. The Zeros and MiGs were superior aircraft to many of those pitted against them, but they were frequently outperformed because of their pilots' limited skills. But when an advanced pilot is put into a superior plane, the road to survival and victory is a more certain one. This is what the United States did with the Sentry fighters and their crews. Korea had taught many lessons about aerial warfare. It was learned that strategic campaigns aimed at destroying an opponent's means of production were sometimes of dubious value, especially if your opponent didn't have the means of making war, but rather relied on an outside supplier. It became confident that there was a vast gulf between world war and limited war. In a limited struggle, aerial warfare became a matter of maintaining air superiority, interdicting the enemy's supplies, and supporting ground troops through battlefront strikes. the F-100 became more and more a tactical fighter bomber. There were faster interceptors and more expensive Mach 2 long-range strike aircraft, but the Super Sabre became the primary battlefield support weapon. Only 203 of the Interceptor A models were ever built. The following C model was a fighter bomber, and 476 of these appeared. The fully dedicated attack version, the F-100D, was built in far greater numbers. 1,274 were produced. The C and D models were out-and-out attack aircraft. The combination of high-speed landing and considerable bulk made the F-100 difficult to stop on landing. If the landing chute blew out, the pilot was set for a very long roll. Most of the planes of the era suffered the same problem and relied on long concrete runways. It was just another thing that the fighter pilots at the time had to accept as a part of the job. The company had given the Super Sabre its name, but for many, it was just too much of a mouthful. The planes came to be known by their crew as Huns, a contraction of F-100. Including 2 C trainers and the 2 prototypes, 2,294 were built. The last of these was delivered in October 1959. From 1957, they equipped 16 U.S. Air Force fighter wings and were a vital weapon in the American arsenal.
When it jumps from its short runway, the plane will accelerate from 0 to 275 miles per hour in 4 seconds. The pilot will experience a 4G force on his body. Zero-length launch provides our Air Force with a tactical capability anywhere without complete reliance on conventional runways for takeoff.
The F-100B project was meant to take advantage of the Hun's reconfiguration into a tactical strike aircraft. The limited speed of the F-100 design around Mach 1.25 prompted a redevelopment effort to make a plane that could approach Mach 2. Features were added to gear the aircraft for tactical fighter bomber missions. These features soon came to dominate the design and included a recess in the hull providing semi-submerged nuclear weapon storage. This innovation was actually rediscovered 30 years later and given the name conformal storage. To safely eject the bombs from this recess, the air intake for the engine was shifted to the top of the fuselage, as it had with the Hun. Tactical consideration came to totally dominate the F-100B. Air Force approval to proceed with the design was given on June 11, 1954. This was followed a month later by the issue of a new designation for the aircraft. The F-100B became the F-107. By that time, the changes had become so radical to the F-107A, really little had left in common with the Hun. The fuselage, in addition to its shark fin intake, was 50% longer than the 100. Like the Super Sabre, the F-107 featured many innovations, including an all-movable vertical tail surface and variable air intake ducts. The plane had also a multitude of built-in equipment, including chaff dispensers, radar beacons, maneuverable autopilot, and computerized stability augmentation. With this avionics package, the F-107A was really a leap into the future of the electronic development. The first F-107A took flight on September 10, 1956, at Edwards Air Force Base. The test series went ahead. Though there were some minor problems evident, North American was increasingly confident that it would all be a hot seller. The 107 was in competition with the Republic F-105, which appeared to be encountering developmental problems and wasn't ready to fly. The fly-offs were postponed. North American referred to the F-107 as the Super Sabre. The biggest worry was that once the 107 won the contract, construction would go to Republic, whose factory had no work of its own. Despite North American's confidence, the decision when announced came down on the side of Republic's F-105. Now, it was obvious that the F-107 would never be built in its numbers. An initial 33 examples had been contracted, but the only 3 test aircraft were fully built. It's said that the 105 won because it's internal bomb bay. Although this feature was never really used, the F-107 was left with the bitter consolation of being one of the best planes not to win an Air Force contract. But the F-107's failure didn't negate the F-100's success, and the Super Sabre soon took its place in the front line of the US Air Force. The late 50s and early 60s was a time of peace, and North America took the chance to refine the plane. The F-100B model, which introduced integrated refueling gear, carried an astounding array of non-nuclear stores. Over 75 weapons, bomb racks, ECM pods, and launchers for rockets, mines, flares, and sundry other attachments were compatible with the plane. The D had a number of significant adjustments, including the landing flaps, greater wing area, and a taller tail. Over the years, the C and D models appeared in a number of many variations. With some different cockpit layouts, 148D models were even equipped with zero-length launch. In 1962, an extensive program was begun to standardize the existing Huns. The program took until 1965 to complete, with an average of 60 days spent to modify each plane. But after the refit, Tactical Air Command finally had what it wanted: a fleet of advanced combat-ready F-100s. The F-100 went to war on the 9th of June 1964. Sent to strike a target in the tiny nation of Laos, 8 pilots flying F-100s attacked the path to Laos' stronghold in a reprisal raid. This was in retaliation for the shooting down of a Navy reconnaissance plane. It would only be the first of hundreds of missions flown over Southeast Asia, where, time and time again, the plane would prove its worth in battle. From the first raid onward, the Huns' involvement gradually escalated. In March 1965, Operation Rolling Thunder began. The United States had become fully entangled in the conflict, and, as the leading tactical fighter on the spot, so did the F-100. Vietnam lacked landing fields or jet-powered aircraft, and the US rapidly began building new installations. These included new bases at Vietnam, Thanh Rang, Phu Quoc, and Tua. All would see immense Super Sabre activity in the years to come. At many locations in Vietnam, pairs of 10,000-foot runways were built together with accommodation, administration, and maintenance facilities. In terms of modern airfields, South Vietnam became one of the most richly endowed nations on Earth. At the peak of their deployment, 490 F-100s were operating from South Vietnamese bases. Other units were stationed in Thailand. Aircrafts and units were rotated so that the most of the Air Force's Sabres saw action at one time or another. Even the two-seat traders arrived on the scene, to be re-equipped as the first Wild Weasel aircraft. They would soon be wreaking devastation on enemy anti-aircraft installations. In 1966, the base at Fan Run was one of the first to receive an all F-100 fighter wing. It remained a center of Super Sabre activity throughout the war. At one time, 140 operated from the field. By the middle of 1967, 4 fighter wings, the 3rd, 31st, 35th, and 37th, were operating the Hun in Vietnam. Although histories of the Vietnam Air War might make only passing reference to the F-100s, it's not because they weren't there in numbers, perhaps not as glamorous as other planes. Their contribution to the war effort was irreplaceable. In long-range strikes against North Vietnam, the Super Sabre's weakness became evident when compared to the newer F-105 and F-4. In such company, the F-100 was definitely outclassed. However, the F-100 served admirably as the aerial artillery so desperately needed by U.S. ground troops. At times, this was the most important task performed by the Air Force, especially to the grunts toughing it out below. To the F-100s operating with forward air controllers or FACs would drop their loads with devastating effect. Their missions can be described simply: briefing, takeoff, refueling, flying to a set of coordinates, rendezvousing with the FAC, locating and attacking targets, finally heading back to the base for more ordnance. A clinical description for what was a devastating endeavor. Pattern of the missions was repetitive, and those missions were flown in vast numbers. As early as 1969, the 4 wings stationed in South Vietnam had flown more combat missions than the combined total of the thousands of T-51 Mustangs engaged in World War II. The intensity never let up, and airfields in South Vietnam became the busiest in the world. In January 1967, figures for the base at Viennos showed 65,000 takeoffs and landings. This translates to 1 every 42 seconds for 31 days. Many of those were F-100s. In light of this, the word busy takes on a new and fuller meaning. As soon as the plane arrived back at base, a de-arming crew cleared the guns and reset the safety pins. Only then could the flurry of maintenance, fueling, and rearming begin. With the crew chiefs checking and rechecking the plane during the process, they were quickly readied for the next action. In practice, the Huns would fly 2 missions a day. Operational readiness figures achieved by the F-100s in Vietnam sometimes registered above 95%, which was a credit to the planes and their crews. The 31st Tactical Fighter Wing operated 5 squadrons of F-100s. This meant that its base, Tiwa, had the highest concentration of Huns in South Vietnam. In addition to its 3 regular squadrons, 2 Air National Guard squadrons were attached to it. The National Guard forces deployed to Vietnam proved to be among the most effective units in the theater, partly due to the age and experience of the pilots, and, in part, of the stability of their personnel. These squadrons shot down the old flying club image of the Air National Guard. Instead, they proved to be a strong and valuable reserve. After their performance under fire, the F-100s phased out of Guard service were replaced with brand new aircraft. In earlier days, they would have been issued hand-me-downs from the regular Air Force. In fact, General George Brown stated that the best 5 F-100 squadrons in Vietnam were National Air Guard units. These 5 included the 2 Guard units attached to the 31st Wing, Atwila, the 136th from New York, and the 188th from New Mexico. Tiwa was another of the new bases begun in May of 1966. By November of that same year, F-100s were operating from the airstrip there. Its temporary aluminum matting runway was still in use long after a concrete runway was laid beside it in 1967. The installation was finally abandoned in mid-1970. With its seemingly endless rounds of raids and replenishment, the activity of TWA wasn't much different from the other F-100 bases of the war. The 31st brought with it about 110 aircraft. 44 National Guard planes were later added, making a total of over 150 Huns. Day and night, the routines at the base went on, with the men working a minimum of 6 days a week to keep up with the deadly rotation of strikes. By the time a plane was ready for its mission, it would be loaded with fuel, ammunitions, and stores to the point where a pilot needed every inch of the airstrip just to take off. Tuy Wa's runway faced out to sea, and, with mountains at the other end of the strip, most landings and takeoff went over the beach. The view may have been nice, but variable sea breezes averaging around 25 knots and blowing across the runways tended to complicate matters. F-100 missions fell into 2 basic categories: planned strikes preceded by extensive briefings, and combat emergencies, responses to urgent calls from help from forward air controllers or army units. F-100s also joined in pilot rescue operations, sometimes providing a wall of suppressive fire encircling enemy troops. The aircraft was fast, and its bases were spread over all of South Vietnam. Planes would often be in the air and over a target within minutes. Sometimes, the men on the ground would call down strikes on only 50 yards from their own positions. This is a tribute to the planes and their pilots, because the grunts on the ground would have to be far more wary for any calling of help, if the Super Sabres hadn't established a solid reputation for getting there fast and hitting only what they shot at. The need for an extreme accuracy in supporting ground troops was an additional and not inconsiderable burden on already tense pilots. Vietnam was a major testing ground for US military hardware, and some of it turned out to be terribly inadequate. The Bullpup missile was a case in point. Against entrenched targets, the toggle-controlled Bullpup wasn't much more than a nuisance, even if their aim was true. And they were less than a total success against reinforced bridges, which were just the kind of target most likely to justify their expensive use. They may have represented the cutting edge of technology one time, but in battle, they proved to a lack of cutting edge of their own. Some of the smart weaponry that showed up later was far more effective and represented a revolution in weaponry that few could have envisioned. Most of the work of the Huns was done with basic ordnance like tumbling, unfinned napalm canisters. And 500 and 750-pound iron bombs of World War II design. In addition, there were 4 cannons, each with 200 rounds, which gave the Super Sabre its lethal strafing power. By 1970, replacement of the F-100s with F-4s and F-111s was proceeding rapidly. Many of the airframes had passed 5,000 hours, and the F-100's age was telling. It had been an old design when it entered in combat, outclassed by opposing MiGs. It was simply no longer in the race as an air superiority weapon. However, it made quite a name for itself in its support of the Army and was also the first Wild Weasel aircraft. As the war drew to a close, the F-100s left Vietnam, unit by unit. The last of the 35th Tactical Wing at Thanh Rang disappeared in July 1971. Huns flew 360,283 sorties in Vietnam, more operational sorties than any other type in that war. 243 of the planes were lost, 198 of those in combat. The majority of the F-100s used in foreign air forces were second-hand. In 1958, the French were the first foreign country to receive new Super Sabres. They operated 100 of them, with 15 of the F models and 85s. These remained in French service until 1980. Denmark also had 3 squadrons of Huns and operated them until 1982, and Taiwan received and operated second-hand A models which were later upgraded. By far, the largest customer for second-hand Super Sabres was Turkey. Out of the over 300 eventually purchased, the Turks reportedly still have some F-100s in storage, but generally, the Super Sabre wasn't a great foreign sales success for North American. And, with the failure of the F-107, they were left without any fighter contracts whatsoever. But North American didn't give up on the fighter building business. On the contrary, they were already working on the Mach 3 F-108 Rapier, which, like the XP-70 Valkyrie, was to be another step into the future. In June 1957, the company was given a contract to develop a proposal that had been initiated in 1955. The plane envisaged would be an interceptor capable of operating at Mach 3 at 70,000 feet. It would have been able to fly 1,000 miles from its base, launching a missile and be back home and on the ground in half an hour. The aim was to destroy incoming missiles or bombers far out at sea. Unfortunately, the plane would have carried an enormous price tag, and after viewing the mock-up in January 1959, the Air Force backed off. On September 23, 1959, North American advised of the Rapier program's cancellation after only 3 generations, all of which had been illustrious ones. The company's days of fighter construction were at an end. After Vietnam, Huns remained in service solely with the National Guard, and by 1972 had completely phased out of the Air Force use. But almost no low-time planes were left. Having become a relic, they were gradually phased out. They had been with the Guard for over 21 years, and several pilots had logged over 5,000 flying hours in them. The last operational National Guard flight was on the 10th of November 1979. The only flights after that were ferrying operations. The F-100 is now a thing of the past. It was the product of an experimental age and bridged 2 separate eras between 1949 and 1979. A lot had happened in aviation. The plane had gone from the world record holder to a non-contender even before its production cycle was over. And although it had no fancy avionics, pilots grew to love it both for the plane it was and for the hard lessons it taught them. Among old Hun jockeys, there is little dissent about what it's worth. At one time, the subject of considerable doubt, the Super Sabre ended its career with a proud reputation, and with the distinction of its performance in Vietnam. That reputation is sure to live on for a very long time.
Aviation, the art of aeronautics, began with the dreamers, inventors, and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks' Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth, and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.